Ever get that feeling? Like when you look up at the night sky and you kind of get this itch, this curiosity. Are we alone out there? I mean, it's a question that's always kind of haunted us, right? And if
Uh,
there are other beings out there looking back, I bet they're wondering the same thing.
I'd say it's a pretty safe bet. It's that basic human need to know, to connect. And that's really what pushed NASA to try and reach out across space
Mm.
to see if anyone's out there.
And that's where the Voyager missions come in. Launched way back in 1977, they were originally designed to explore the outer planets, Jupiter, Saturn, that kind of thing. But they didn't start there.
Not at all.
Voyager 1 and Voyager 2, they're two of only 5 spacecraft to ever leave our solar system and head out into interstellar space. Just just think about that for a second. 5 little things made by humans out there drifting between the stars.
Pretty mind-blowing, isn't it? And the distances are just, well, Voyager 1 is something like 24.7 billion kilometers away as of October 2024, the farthest anything made by humans has ever traveled.
That's almost impossible to even imagine. But for our deep dive today, what makes these two Voyager probes so interesting is that they're carrying messages for any aliens out there who might stumble upon them.
Messages from Earth, a cosmic calling card. It really makes you think, what would you say to represent an entire planet?
Yeah, that's a huge question.
Yeah.
But to understand what those messages say, we got to look at why and how these Voyager missions even happened in the first place. Why launch them in the 1970s?
Well, the timing wasn't random. The late 1970s saw an incredibly rare alignment of the outer planets, Jupiter, Saturn, Uranus, Neptune. It happens only about once every 175 years. And this alignment gave NASA a chance to use something called gravity assist.
Gravity assist. Now that sounds like something straight out of Star Wars.
Uh-huh. It's actually really clever. Imagine it like a slingshot, but on a cosmic scale. When a spacecraft flies close to a planet, it can use that planet's gravity to speed up and change direction without using much fuel. And with all those planets lined up, it meant that a single spacecraft could visit all 4 of those gas giants pretty quickly, pretty efficiently.
So this rare planetary alignment, this is the real reason why 1977 was the launch year for both Voyagers. Like, it wasn't just a good year, it was a once-in-a-lifetime opportunity.
Exactly. And NASA made sure to take advantage of it, sending those probes on these amazing trajectories to visit multiple planets. And each Voyager, they had their own set of targets.
Voyager 1, if I remember correctly, was primarily focused on Jupiter and Saturn, particularly Saturn's moon, Titan. That one's always been kind of a mystery.
That's right. Titan, it's got this thick atmosphere, pretty unusual for a moon, made it a high priority for study. In Voyager 2, its mission was even more ambitious. Jupiter, Saturn, Uranus, and Neptune. And it's still the only spacecraft to ever fly by Uranus and Neptune.
I can't even imagine the pictures and data it sent back from those icy worlds. But to power a mission that far out, you can't just rely on solar panels, right? Especially when you're going that far away from the sun.
Absolutely. Solar energy gets weaker and weaker the farther you get from the sun. By the time you're out of Jupiter or further, there's just not enough sunlight to power a spacecraft. That's why both Voyagers were equipped with these things called radioisotope thermoelectric generators, or RTGs for short.
RTGs, that sounds pretty high tech. So how do those things actually work?
Well, they use the heat from the radioactive decay of plutonium to generate electricity. It's a long-lasting power source, perfect for when you're way out in deep space. And to do all those scientific studies, the Voyagers had to have some pretty amazing instruments on board.
They were like flying laboratories.
Right. Each Voyager carried a bunch of scientific instruments. They had a 2-camera system for taking those incredible photos, different kinds of spectrometers for studying the composition of atmospheres in space itself, a magnetometer for measuring magnetic fields, and of course the high-gain antenna.
Right, the high gain antenna. That's what allowed them to communicate with Earth over all those billions of kilometers to send back those incredible images.
Exactly. That antenna was vital. And, the launches themselves had a bit of a twist to them.
Oh, what was that?
Voyager 2 actually launched first, August 20, 1977. Voyager 1 followed a couple of weeks later on September 5. But Voyager 1 was sent on a faster trajectory, so it actually got to Jupiter first.
Like a cosmic game of leapfrog. So once they started their tours, what were some of the big discoveries they made?
Voyager 1 got to Jupiter in March 1979. Almost immediately, it started sending back amazing data, including this amazing time-lapse of Jupiter's rotation, made up of 66 photos taken over about 10 hours.
Wow.
They were the clearest photos we'd ever seen of Jupiter and its moons. Oh, and Voyager 1 also confirmed that Jupiter has rings.
Rings around Jupiter. I thought only Saturn had those big impressive rings.
A lot of people think that, but actually Jupiter, Uranus, and Neptune all have rings. They're just fainter and harder to see from Earth.
Mm.
But yeah, those rings were a big discovery.
So we call Jupiter and all its moons and rings the Jovian system. And Jupiter, Saturn, Uranus, Neptune, they're all known as the Jovian planets, or gas giants. They're these massive worlds with thick atmospheres, rings, and lots of moons.
Exactly. And speaking of moons, Voyager 1 found something pretty incredible on one of Jupiter's moons, Io. It discovered active volcanoes.
Volcanoes erupting on another world?
Yeah, the first time we'd ever seen active volcanoes anywhere other than Earth. It showed us just how dynamic and alive these other worlds could be.
Incredible. And then Voyager 2 got to Jupiter a few months later. What did it find?
It did a closer flyby of Jupiter in July 1979 and actually found another moon, bringing the total number we knew about up to 16.
Wow.
And today we know that Jupiter has at least 95 moons.
95. That's mind-blowing.
It is. These missions really changed everything we knew about these planets and their systems. So after Jupiter, Voyager 1 headed on to Saturn, arriving in November 1980. It was traveling even faster than Voyager 2, which took another 9 months to catch up. At Saturn, Voyager 1 found 3 more new moons: Atlas, Prometheus, and Pandora.
Pandora. That sounds familiar. That's the name of the alien world in the movie Avatar, right?
That's right.
Cool little connection there.
Back then, we knew of about 15 moons around Saturn. Today, we know there are at least 146. And Voyager 1 got some really amazing pictures of a lot of them, especially Saturn's largest moon, Titan.
Titan's always been a fascinating place for scientists. That thick atmosphere, the possibility of liquid on the surface. It's like something out of science fiction.
And it's true. Apart from Earth, Titan's the only place in our solar system where I know for sure there's liquid on the surface. Not water, but liquid methane and ethane. And scientists think there might even be oceans of water underground.
And after those amazing flybys of the gas giants, both Voyagers began their separate journeys out of the solar system, each taking its own path. Voyager 1, after Saturn, it left what we call the ecliptic plane, right?
Right. The ecliptic plane is basically the flat disk where most of the planets orbit the sun. Think of the solar system like a giant dinner plate.
A cosmic dinner plate. I like that.
And most of the planets stay pretty close to that plate as they go around the sun. But Voyager 1 was sent on a trajectory that took it above and beyond that plane.
And Voyager 2 kept going on its grand tour, making those historic visits to Uranus and Neptune.
It did. Voyager 2 is the only spacecraft to ever fly by those two ice giants. And all the while, Voyager 1, thanks to those gravity assists it got from Jupiter and Saturn, it was speeding through space at over 60,000 kilometers per hour.
Seriously, that's unbelievably fast. And that's when their interstellar mission really began, their journey beyond the sun's influence.
Right. January 1st, 1990, that's the official start date of their interstellar mission. And just a little over a month later, Voyager 1 took one of the most iconic photos in space history, the pale blue dot.
Yeah, that photo, it really makes you think about our place in the universe. It makes Earth seem so small and fragile.
It does. From 6 billion kilometers away, Earth looks like just a tiny speck of blue against the darkness of space.
You really get a sense of perspective when you see that.
You do. And in that photo, you could also see Venus, Earth, Jupiter, Saturn, Uranus, and Neptune, all as these faint points of light. But Mercury, Mars, and Pluto, they were too small and faint to see at that distance.
And after that photo, Voyager 1's cameras were turned off for good.
Yes, they were shut down to save power and memory. Voyager 1 was headed out into deep space. There wasn't much more to see. And then in 1998, it became the farthest human-made object, overtaking Pioneer 10. And then in 2004, it crossed the termination shock.
The termination shock, that sounds ominous.
It's not as scary as it sounds.
Okay.
The termination shock is the region where the solar wind, which is this constant stream of particles coming from the sun, starts to slow down as it runs into the interstellar medium, the stuff between the stars.
Okay, so the solar wind creates this bubble around our solar system called the heliosphere, and the termination shock is like the outer layer of that bubble.
Exactly. But the true edge of the heliosphere is called the heliopause. That's where the solar wind completely stops. And for a long time, scientists also thought there might be this thing called a bow shock even further out, where the heliosphere crashes into the interstellar wind.
But when did Voyager 1 actually cross the heliopause? When did it officially enter interstellar space?
That happened on August 25, 2012. It took Voyager 1 22 years to get there. NASA took over a year to analyze all the data and officially confirm it, but yeah, that's when Voyager 1 left our solar system. And interestingly, that crossing also changed our understanding of the bow shock. Now we think it's more of a gradual transition zone than a hard boundary.
How did scientists actually know when it crossed over? What gave it away?
Well, there was this big solar eruption back in 2012. It caused the electrons around Voyager 1 to vibrate. And using the spacecraft's plasma wave instrument, scientists measured a sudden jump in the density of those electrons, much higher than what they had measured inside the heliosphere. That higher density was the sign. Voyager 1 was in interstellar space.
Wow, it's amazing that we can detect those kinds of changes across such vast distances.
It really is.
Yeah.
And it wouldn't be possible without the Deep Space Network. Those huge radio antennas in California, Spain, and Australia, they're constantly listening for those faint signals from our distant spacecraft.
It's incredible technology.
It is.
And Voyager 2 actually followed suit and entered interstellar space on November 5, 2018.
That's right. So now we have two spacecraft out there in interstellar space, and they're carrying these special messages for any aliens they might meet. Though the Voyager records weren't our first attempt at sending messages into space, were they?
No, I remember reading about the Pioneer plaques. Those were attached to Pioneer 10 and 11, kind of like a first draft of a message to the stars.
Right. They were much simpler. Each Pioneer plaque was a small rectangular plate made of gold anodized aluminum, about 15 by 23 centimeters. NASA called it a mark of man, basically a way to tell aliens where Earth is and who we are.
What kind of information did those plaques actually contain?
Well, they had 5 main diagrams engraved on them. There was this radial map showing the sun's position relative to 14 pulsars, which are these rapidly spinning neutron stars that give off very regular pulses of radiation. They're like cosmic lighthouses. And then there was a diagram of our solar system with an arrow pointing from the sun to Earth, showing where the spacecraft came from.
Okay.
And there was a silhouette of the Pioneer spacecraft itself to give a sense of scale. And finally, there were simple drawings of a man and a woman without any clothes.
So just the very basics, a kind of cosmic hello, and this is where we are.
Pretty much. They were groundbreaking for their time, but they could only carry so much information. And that's where the Voyager missions come in. That's where the golden records come in.
The golden records. These are much more complex, right? And they're actual phonograph records. It's such a cool, old school way to send a message across the galaxy.
I know, right? It's almost poetic. Each Voyager carries two 12-inch gold-plated copper discs, basically phonograph records. And they don't just have images. They have sounds and music from Earth, too.
It's like a time capsule of our planet.
It is. The content on the records is divided into 4 main sections.
Okay. What's the first section?
It's called Scenes from Earth. This section has 115 images and diagrams. They cover lots of different things, from basic math and physics to pictures of Earth's geography, its ecosystems, and all kinds of life, plants, and animals. It's like a visual encyclopedia of our planet.
Wow. It's amazing to think about all the things they chose to include. And I heard there are also spoken greetings in lots of different languages.
Yeah, there's a section called Greetings from Earth. It includes spoken greetings in 55 different languages. There are also printed messages from President Jimmy Carter and UN Secretary General Kurt Waldheim.
So it's like a chorus of voices from Earth.
It is. And of course, there's no guarantee that aliens would be able to understand any of our languages, but it's a gesture of, well, of goodwill.
A message of peace and connection.
Right. And then there's the Music from Earth section.
The soundtrack of humanity. I bet choosing the music was a tough job.
It was. They picked 28 pieces of music representing lots of different cultures and historical periods, from classical music to folk music to traditional music from all over the world.
It's like a mixtape for the galaxy.
Haha, yeah, something like that.
And what about the last section?
That's called Sounds of Earth.
Oh.
This section has 21 recordings of sounds from Earth. Things like wind, rain, thunder, animal sounds. They even included the sounds of people laughing and walking and machines working.
It's like they were trying to give aliens a sense of what it's actually like to be on Earth.
Exactly. They wanted to capture the soundscape of our planet.
I have a question, though. Let's say some alien civilization actually finds one of these golden records out there in space. How would they even know how to play it? How would they get the information off of it?
Well, the Voyager team thought about that. They included instructions on how to play the record, engraved on the record's cover.
Instructions for aliens. I hope those instructions are really clear. I mean, can you imagine trying to explain a record player to someone who's never even seen one before?
It would be tough. And you know, even for us today, those diagrams aren't that easy to understand. It takes a bit of figuring out.
It really makes you wonder if aliens would be able to decode those instructions. It'd be pretty amazing if they could. But what about the pictures? I understand that storing digital images like we do today wasn't really possible back in 1977. So how did they fit 115 images onto those records?
That was another really clever workaround by the Voyager team. The computers on the spacecraft were very limited, only 69 kilobytes of memory. That's not even enough for one low-resolution photo today. So they had to convert the images into audio signal.
Audio signals. So the pictures are literally encoded as sound.
Exactly. They projected each image onto a screen, recorded it using a TV camera, and then stored that video signal as audio on the record.
Wow, that's so innovative. So to see those images, aliens would have to reverse that process, convert the audio back into visuals using those instructions.
That's right.
So what kind of images are actually on there?
Well, the first image is just a simple white circle, a calibration image to help aliens decode the rest of the images.
A visual starting point.
Right. And then there are diagrams showing basic math and physics, units of measurement, things like that. And then there are diagrams of our solar system, including Pluto.
Pluto was still considered a planet back then.
It was.
So is there anything else?
Oh, yeah, there are actual photographs of Mercury, Mars, Earth, and Jupiter. Some of them even have little symbols and equations to explain what's in the picture. Like, there's this image of Egypt, the Red Sea, and the Nile River, and next to it, it says that Earth's atmosphere is 78% nitrogen.
Cool.
There are also models of hydrogen, carbon, nitrogen, oxygen, and phosphorus, the building blocks of life.
Right.
And then there are two images showing the structure of DNA and how cells divide, the basics of life.
Wow, that's a lot to pack into 115 images.
They had to be very selective.
What else?
Oh, and then they included about 20 images showing different aspects of human life. People doing everyday things like licking an ice cream cone, eating, drinking. There were images of human anatomy. And then famous landmarks like the Great Wall of China and the Taj Mahal representing human civilization.
So it's a very positive and hopeful view of humanity, right?
Yes,
Yeah.
very deliberately. Carl Sagan, who was one of the people behind the Golden Record, he said they wanted to present a good image of ourselves to show our potential, not our flaws. So they didn't include anything about war, poverty, or environmental problems.
Just like they were saying, this is the best of us, this is what we can be.
Exactly.
But it does make you wonder, will those messages ever reach anyone? And if they do, will those beings even understand them?
Those are the big questions. And unfortunately, we don't have the answers. Space is so vast, and the distances between stars are so huge. It's statistically very unlikely that the Voyagers will ever be found by another civilization. And even if they are, there's no guarantee that those aliens would be able to decode the records. They might not even have the same senses as we do. They might not even perceive the universe in the same way.
It's a long shot, but it's still amazing to think that those messages are out there.
It is.
So where are those two Voyagers now? Still going strong.
Oh, definitely. Voyager 1 is speeding through interstellar space at over 61,000 kilometers per hour. It's about 25 billion kilometers away from Earth.
Still going. But their power won't last forever, right?
No, eventually they will go quiet.
It makes you feel, I don't know, a bit melancholic.
I understand.
Their power comes from the decay of plutonium in those RTGs. Eventually, they will run out of power.
Scientists think that by around 2025, they'll be too weak to operate their instruments.
And then eventually, no more communication with Earth.
That's right. But those golden records, they'll keep going. They'll keep drifting through space for millions, maybe billions of years.
Long after we're gone, it really makes you think, what does it even mean to send a message across the stars? What kind of legacy are those records creating? I mean, whether they're ever found or not, it's just such a powerful gesture. It speaks to our curiosity, our hope. It really captures that human desire to connect, to reach out, to know that we're not alone in the universe.
It truly is an amazing thought. A tiny piece of us, traveling out there among the stars, carrying our story, a story that might one day be heard.
And on that note, we'll end this deep dive into the Voyager missions, but it's definitely something to think about. What would you put on a golden record if you had the chance? What would you want to tell the universe about us?